morning, everyone. It is my great pleasure to introduce our visitor, Professor Giorgio Buonanno from the University of Cassino and San Lazio. Well, while Giorgio came to us from far away, Giorgio is part of our team, and in fact, Giorgio is also an adjunct professor here at QUT. During some meetings and presentations yesterday, and preparing my presentations about what we achieved as our large and interdisciplinary team, and highlighting the most important contributions we made, particularly applied contributions, I realized that those contributions, all of them, were related to collaboration with Giorgio and an inspiration from Giorgio. So it's always great to have you here with us and work with you across the oceans and continents. I'm not going to say much more about your interests and what you do, in addition to what you are going to tell us during the presentation. But if you want to say a little bit more about whatever you want to say, over to you.
Thank you very much. So thank you, Lydia, for your kind introduction. I am a mechanical engineer, but in principle I am a thermodynamics. So this is the reason that was forced me to come here something like 20 years ago, because I was working on airborne particles, and at that time there was a young professor here working on the same topic. That was Lydia, and for me Lydia was a reference for my work. Lydia said that I helped in some inspiration, but the inspiration that I received from Lydia was very important, and I hope that today this topic could be of inspiration for you, because it's something that I want to share here, some reflections and data on issues that concerns public health, workers' safety, and indoor air quality. Is a topic we are working on this topic, but is a recent topic for us. So it is good for me also to receive some comments from you. So what is this topic? Environmental cleaning and disinfection, one of the most important activities for the prevention and control of infections. This is a very important activity, but an overlooked side of infection control is how surface and air disinfection, that are very important, can generate pollution that affect indoor air, and of course that can be a risk for workers' health. So the key question is, how can we ensure effective disinfection without compromising air quality? Because there is also always a balance between these two aspects. I will share preliminary or some experimental data, exposure models, and possible strategies to achieve this balance. So I want to start with the possible way of transmissions of pathogens. We can have vector-borne, food-borne, of course, regards pathogens that follow this way of transmission. But for this presentation, more important, waterborne, bloodborne, and airborne. Sorry, Lydia, I will consider in this slide the terminology that is not the terminology of the last document that was published by the WHO. And this document, we contribute, both of us, to this document, but I adopted the terminology airborne in order to consider the transmission in the air. Okay. Of course, surface is an important way of transmission for example, indirect or direct contact. As regards indoor environmental quality, this is a very complex problem, and pathogens probably is considered only here, only for indoor air quality, without considering other aspects like visual comfort, indoor thermal comfort, and so on. So let's start with the disinfection of surfaces. WHO and of course US CDC highlights the importance of cleaning and disinfections in all healthcare settings. And these recommendations were enforced during the pandemic, and there was an increase of the frequency of the surface disinfection. I suppose also here in Australia, but in Italy it was the rule. In principle, there is a list of disinfectants that are also very different one from the others. As an example, alcohol, chlorine and chlorine compounds, and hydrogen peroxide, and so on. Occupational exposure is a public health concern because it could affect something like 65 million healthcare workers worldwide. And among the disinfectants, chlorine-based agents such as sodium hypochlorite, so bleach, are used because the efficiency is very good and also the cost, they are very cheap. And consider that most of the epidemics occur in developing countries where, of course, it is very important to have cheap, very cheap disinfectants. These agents were recommended by the WHO both in routine healthcare settings and during outbreaks, of course. But this has been associated with an increased risk of respiratory conditions, for example, asthma or chronic obstructive pulmonary disease. So the first question is, could disinfection actions lead to emission of pollution? From bleach, we know in some way that we could have emission of chlorine gas. And chlorine gas is documented as a cause of acute respiratory disease or stress. It's very important to understand that this action is an action in a short term. So there is the exposure, and in a short term you can observe the effects. But there is the other pollutant, and you know this, ultrafine particles, because we can have the generation of ultrafine particles using bleach, for example. What is the difference? The difference is that ultrafine particles is a pollutant that has to be considered as systemic, the response. So it is not interested in the short term, but the long term of the exposure. And probably this is the reason why health communities take care of chlorine gas and not ultrafine particles, probably also because they don't know that we can have this contribution. So we started to measure to investigate, to measure the emission of chlorine gas and ultrafine particles during disinfection using bleach, and focusing on the effect, on the influence of temperature, light, and organic substances. So we performed tests in a chamber. We have a chamber in my laboratory. This chamber was characterized in the past and also during this experiment, so we know the air change rate inside this chamber. And we use instrumentation that you know very well, for example, a couple of butanol condensation particle counters, TSI 3775, able to measure particles up to 4 nanometers, SMPS, and a fast mobility particle sizers, and then portable gas detector to measure chlorine gas, as well as lux meter sensor. Tests were carried out by dispersing the bleach in a vessel. The surface of the vessel was 1 square meter. And of course, the vessel was cleaned prior to each experiment. And inside the chamber, we use an air purifier, high performance air purifier, in order to have a background concentration before the injection of the bleach lower than 100 particles per cubic centimeter. We use for each experiment a solution that is in agreement with the infection prevention and control recommendation. The solution was prepared daily, and we perform also some tests under typical room light conditions without bleach, control tests, in order to check if there were other sources able to generate ultrafine particles in particular. Then we performed tests with bleach at different temperature. Low temperature, it means 22 degrees Celsius, because we don't expect a lower temperature in healthcare settings. Medium temperature, around 26 degrees Celsius, and high temperature, very high temperature, simulating the conditions that my colleague is a PhD student, Luca Fontana, but in principle is one of the main experts of Ebola transmission. And when Luca goes to developing countries to manage this kind of infections, the normal temperature is well above 35 degrees Celsius, very high humidity, and also the radiation could be very high. So in order to simulate the radiation, we use a particular lamp, and we were able to vary this irradiation. Then we evaluate also the impact, the presence of different organic contaminants for the generation of chlorine gases. And in particular, we use different substances like vomit. Of course, we did not use directly vomit, but urine, yes, blood, and 2 different soaps. Instead to use vomit, we use hydrochloric acid, 10% hydrochloric acid, that to replicate the chemical properties of stomach contents. Urine and blood were collected from healthy adult male from chicken, but we are sure that the reactions are the same. For each test, we repeated 3 tests, and at the end, we perform also an experiment in a real-world scenario, so in an office. So we repeat the procedure with the air purifier, we decrease the concentration, and then we introduce the disinfection in order to measure the emission of ultrafine particles. We performed this test in 2 rooms. In one of these rooms, we performed the cleaning before the sanification, the disinfection. In the second room, we did not perform the cleaning. So here I'm reporting some data. You can see the concentration in the chamber, and this is the time from the introduction of the bleach. This trend is obtained at a temperature, low temperature, so it means between 22 and 26 degrees Celsius. And this is the trend of the concentration of ultrafine particles without the bleach, so in the control. So you can see that there is a strong increase because, of course, there is the generation of these ultrafine particles. What about high temperature or high radiation? There is a very strong increase of the concentration. These scales are different. This is 100,000, this is 35,000. So it is very important to highlight the importance of the temperature that increase the generation of these particles. In this figure, you can find similar graphs representing the generation of particles in the case of the blood, vomit, or soap, urine, and soap with ammonia. And the last graph, the generation of chlorine gas. Of course, the worst condition is when there is the presence of the vomit. In principle, we have a generation of chlorine gas where we have contaminants. And this is the reason why WHO recommends to clean before to disinfect. But this action doesn't avoid the generation of ultrafine particles, because even if we have a cleaned surface, in some condition we have the generation of ultrafine particles. What is the dimension of these particles? Okay, is around 10-20 nanometers. But on the basis of this data, we were able to estimate the emission factor. I reported here the mass balance equation developed by Congron. I don't know if Congron is attending this meeting. And at the end, with this equation, you can find here the emission factor for each of the cases that we have considered. So low temperature, medium temperature, high temperature, and so on. So very high emission were found for high temperature, radiation exposure, and urine, the presence of urine. In terms of chlorine gas, the worst conditions were with the vomit and urine. So there is a balance, I repeat, between the emission of ultrafine particles and urine chlorine gases. And there is also a consideration as regards time to emissions. This time to emission is very short, the order of magnitude of seconds when the temperature is very high, minus if you have a lower temperature. So But this is the emission. Exposure is another problem. So we have to investigate if this emission is enough to affect indoor air quality in a typical room in an hospital or in a healthcare settings. So we have to move from the emission to the exposure. So what is the way to disinfect a surface? In principle, you can use the spraying method or wiping. What is better for you? What is better, to spray or to wipe? For you to wipe, why? Yeah? Particles are more airborne. We are considering now the generation of pollution. Okay. So your comment is in agreement with the WHO recommendation. That probably is not the best. Why? Of course, we know that chlorine spraying has raised concerns about occupational health risks. But the WHO recently bans direct spraying of bleach, and the WHO prefer wiping instead of spraying. Okay, but what is the problem? That there are not systematic review that can, in a certain way, confirm this comparison. So why it is better wiping in respect to spraying? And there is another problem, very important. Wiping is labor intensive and time consuming. Consider the problem to disinfect a room in developing countries. Okay, when you are completely, you have problem if the temperature is very high, the humidity is very high. So we perform, for this reason, a comparison in order to evaluate the exposure of workers adopting these two different ways of disinfections. And so we perform a disinfection in a room, the same room, using spraying and wiping, measuring in this room the two different emission factors. And we found 3 times 10 to the 8 particles per minute in the case of spraying, 2 times 10 to the 8 particles per minute. So is there a difference? No. From a statistical point of view, there is not a difference. Okay. So in principle, the emission factor is the same. So in terms to evaluate the exposure, the next step is to understand the time. How long is the disinfection when you use wiping? And for this, we perform measurement in collaboration with Medici Senza Frontiere in Geneva. And they perform tens of sanifications in a room only to estimate the time. And the average time for spraying was 9 minutes. For wiping was 25 minutes to disinfect this typical room. This is a comparison. So on the basis of this difference, the difference in the dose, there was a difference in the dose, not because of the emission, but because of the time. Okay? So, and we found that for each for this room, for each cycle of disinfection, we had 3 times more the dose using wiping in respect to spraying. But this is a typical case. So we extend this to the typical room in healthcare settings. And this is the difference. So we have the same emission factor, so we can consider the same emission factors also if we have vomit or in different situations. And so this is the difference in the dose as the air change rates varies. These are not the limits, but the recommendations of the WHO, 10,000 for the daily value and 20,000 for 1 hour, exposure to 1 hour. And what about this? We did the same for chlorine. You can see that, for example, this is an example. If we have the case of high temperature here, we have an emission of chlorine gas. But if the disinfection is performed by spraying, then we have a safety condition, because this is always lower than the 1 hour threshold value that is suggested by the WHO. So we can manage this. We can estimate the conditions in order to have a good indoor air quality, because we have measured the emission. And there is another consideration that, in my opinion, could be of interest for you. Here you can find the inhalation dose in the case of medium temperature. So the typical conditions, the conditions that are suggested by the WHO. And these are the air change rates, the dose. You can see that for each disinfection, the inhalation dose through the wiping method can reach 3 times 10 to the 9 particles. Is this a very high, a low value? If we consider concentration of 10,000 particles per cubic centimeter for 1 day, this is the limit, we have, this is not here, I'm saying the truth. We have 1 10 to the 11 particles that are inhaled, but consider 10,000. Consider that how many cycles of disinfections are performed by a worker during 1 day? 8, sometimes 10. So you have to multiply this for 10. And it means that, in principle, I can have 3 times 10 to the 9 particles can be inhalated in the case of wiping. This is an order of magnitude, of course. So a concentration of 1,000 particles for 1 day correspond to about 10 to 10 particles. So each in 1 day for 6-8 cycles, the inhalation could be something like 2 times 10 to the 10 particles. So something like the exposure of 2,000 particles per day. And consider that we did a study years ago estimating the dose of Australian people, and even if the concentration of the outdoor concentration is well lower 10,000 particles per cubic centimeter, the dose of Australian people were higher in respect to the one expected from 10,000 particles. Why? Because there is the impact of indoor sources. And for the workers, this could be an important source. And this is the best conditions for them. So low temperature, clean surfaces. So let me go now quick to disinfection of air, because this is disinfection of surfaces. What about disinfection of air? I found this paper some years ago that in this paper, titanium dioxide doped with silver nanoparticles was applied to adhesive photocatalytic films. So you can apply this film, for example, to the windows. And they said, okay, if you apply this to the windows, there is a disinfection of the air. Of course, there is an emission of reactive oxygen species. And we know, okay, there is a disinfection, but what about the pollution? Because we have in indoor spaces box, so we can have the oxidation also of the species and the generation of ultrafine particles. So, and in this paper, there is a clear efficiency of this material in order to disinfect the air. Oh, very good, because it's quite cheap. This methodology is cheap, very cheap, very easy, but the problem is here. Could be here. So we performed the same test for the bleach using these adhesive films with the irradiation of the lamp. And you can see here in one test the generation of particles, very high, the concentration, and the emission factor is 2, 3, 10 to 12 particles per minute. Very efficient, okay, but the generation of ultrafine particles could be very high. And finally, there are also some paints. This is an Italian paint, and this paint has the same job of these films. So you can buy this paint, it's very expensive, but this paint can protect you and disinfect the air. What about the emission of this paint? The same. And this is the emission factor. Of course. So this is the final slide for me, because I want to transmit to you a comparison between the emission factor for indoor sources in order to understand the possible impact of this source, because in principle these are sources of ultrafine particles. You can see here all these data were obtained by studies performed by our group together. Okay. You can see these are combustion sources. So cooking activity, candles, surgical procedures, okay. Smokers, open fireplace, pellet stove, welding, and so on. This part. The second block, the second group are this one, so breathing and vaping. Not combustion, but we know that there is a generation of ultrafine particles. 11 is cleaning product. Cleaning product is another family of product that can generate ultrafine particles. And at the end, here, disinfection bleach, disinfection adhesive film, disinfection paint. These values seem not so high, but consider that this is the emission for 1 square meter, only one. So you have to multiply for at least for 10 square meters, increase 1 order of magnitude. So in my opinion, this way, there are two considerations. For the healthcare settings, it's important to know the problem in order to manage the issue. This is not, in my opinion, science, let me say this. It's a kind of applied science that in some cases is more important than pure science, the application of science. So, what are the take-home messages for you, particularly for the students? Chlorine-based agents can release chlorine gas and ultrafine particles. So there is a risk, a respiratory risk. And we can have a balance between ventilation and the risk in order to mitigate the impact. And let me come back to this slide. So in this slide, pathogens cannot be related only to indoor air quality. Pathogens have to be related also to thermal comfort because there is humidity, temperature that can influence during the disinfection, the emission, but also visual comfort because there is the light. So again, any problem in indoor environments, something that requires a integrated strategy. This is very, very important. Thank you.
Thank you, Giorgio, for this amazing presentation and the extremely important topic. I had sort of 3 different thoughts, much broader thought than just this specific product, but all related to this work, and then we'll open the question. The first is an ongoing discussion of the last few days in relation to the coming events, the conference next week, and then some meetings in Canberra, about the products or procedures complying with standards. Because the approach is such, this would be the bleach industry, any other industry, they would say, we comply with the standards, and they could list the standards list like this, complying with the standards. But what is the standard for, and what's the purpose of the standard? If in that standard, indoor air quality or whatever specific aspect we are considering is not including, so the fact that there's a compliance with the standard does nothing about the specific issue. So this is now a very active discussion, and I think we will do some sort of more job about this. Now, another issue is the whole topic of cleaning, which is growing bigger as well. We had that conversation with Heidi and with Tunga when they were here last year, and actually not sure what's the status of that paper where we summarize this, the impact of the cleaning. But the bottom line is that there's big industry behind cleaning and behind cleaning products. And if you go to a supermarket, the shelves and shelves and shelves. And this is trying to tell you that if you don't clean, and I'm not talking about healthcare industry because it's a very different environment, but I'm talking about stuff for our offices, for our homes. So buy all these products and clean and clean and clean because it's good for the industry. But they've been tested, not this kind of test, but test of what those products do one body doing this was the Choice. There's the Choice customer group. And they show that many of these products don't do much better or the same as water. So you buy a product to clean your floor, and then, well, you might do it as well with the water. So that's right, yes. So you are paying for those things. You are introducing this kind of things, and it's not doing absolutely anything for you but for the industry. So this whole topic is something which we scientists need to take into account and work on this. And also another aspect of this, that this increases antimicrobial resistance, because some of them. So that's a very, very important. So fighting against, in this case, again, cleaning products which are not necessary and not do anything, it's extremely important. But the last point here is, and we should be prepared to answer this question, is we are talking about secondary particles in these products, liquid particles. Now, there is still a debate and an answer question, what are the health impacts of secondary particles versus primary particles, solid particles versus liquid particles. There's no consistent answer to this. The Italians, the Spanish study sometimes show that. So, and that's why the WHO guidelines recommend monitoring size distribution to be able to answer the question whether the particles are secondary or primary. So, anyway, we don't know whether the impact of this is worse than primary particles, but well, it's a particles.
Any case, I prefer an environment without also liquid particles.
All right, these are my comments. Any questions from the room? Laura.
Now, in your opinion, these okay, they get stuck. In your opinion, these particles that are formed from bleach, is bleach what forms the particle, or does bleach, especially with UV light, contribute to the formation of chlorine free radicals? Then that react with whatever is in the air, forming particles.
Yeah, it's a very complex reaction there. And in principle, we don't know exactly what is the...
Roughly, so do you think it's directly bleach, or is it the free radicals, addition of chlorine radicals that enhances the formation?
Free radicals, I suppose.
Yeah. Then that would mean that the emission rate from cleaning would strongly depend on your actual concentration of whatever you have in the air, VOCs.
Yeah, of course. Yes, of course.
Which means that if you have rooms which have higher concentration of VOCs,
for sure,
you could have a much worse problem.
I have not mentioned this in my presentation, but I agree. I completely agree.
So you could even underestimate the emission factors.
Yeah.
Especially if you do that in, let's say, in a chamber where everything is clean, etc.
Exactly.
Yeah.
There's Emily who raised her hand. Emily, would you like to ask a question?
Yes, thank you so much. This was such an interesting presentation. I was just really curious on a very similar topic about the emission factors. Again, I'm assuming that...
Sorry, Emily, could you please speak up? I don't know whether it's our system here, but so if you can please speak up because we can't hear you well.
Okay. Can you hear me any better?
Right.
Try maybe increase it here only.
Right.
Try again.
Hello, can you hear me?
Much better, yeah. It was from our side. Yes.
Okay, thank you. A very similar related question. I'm very curious about your emission factors, just because for secondary particles, your emission factors are going to be highly sensitive to oxidants. So I'm curious, particularly when you were doing the comparison between fogging and surface cleaning, how representative were your oxidant conditions in the experiments that determined emission factors? And have you considered how that would play in a real life hospital setting where, for example, there's potentially less natural light than, direct UV because, it's indoors and that kind of
UV,
thing?
we don't have UV here. So if I understand the question is what could be the conditions in a hospital that could be different from a control room, correct?
Well, I'm just very curious about your emission factors because
Yes.
I would guess emission factors of a secondary species, very similar to the question from the first person.
Yeah.
Your emission factors of a secondary species are going to be highly sensitive to oxidants. So I was just very curious for your emission factors, what oxidant levels were you using?
Oxygen,
Ozone, OH, that kind of thing.
No, I don't use ozone. This is only using bleach. There is no ozone.
Then how are you getting particles if there's no oxidants?
That from chlorine. Yeah.
Sorry, the only product which was used was the bleach. There was nothing.
Only the bleach. Was only bleach. Okay.
Chloride or free radicals. What I think happened is that because you have emissions of chlorine, you're getting, instead of OH radicals being the dominant oxidant, you're getting chloride radicals being the dominant oxidants here.
Yeah.
I'm just very curious. I'm very interested to see, because there's been previous literature that has done experiments with surface bleach cleaning. And unless you have significant VOCs preceding it, they don't see any elevation in the particles just from surface cleaning. So I'm trying to reconcile your study with the previous literature.
But we performed the test in a room with the presence of VOC.
Okay.
But VOCs were not added. They were naturally present, but they were present.
Each step was the natural concentration of VOC in the room. In fact, we repeated each test, one test for each day. We were not in the condition to repeat a second test after the first one, because in this case, the emission factor was practically zero. So we used the VOC concentration present in the environment. It is necessary the presence of VOCs.
And of course, there is also always some concentration of VOCs.
Of course, there is always.
Yeah. So air wasn't cleaned from VOCs.
Yeah, exactly. But yes, anyway, please. Just a comment. Something that I can say that this trend, you can see this trend, there is an increase of ultrafine particles, and then there is a stop of the increase. And at the end here, all the VOCs were used for this process, and after this, there is a stop of the generation. If we perform a second test after this one, we do not observe any generation, because of course we need VOCs, but VOCs are in the environment.
Thank you for your presentation. Just a question about the implications from this, relating back to the slide where you talked about the difference between the effect on the worker with the time spent in the room.
This one?
No, I think it was a bit earlier. It was about how spraying carried a lower total emission or total rest of the work. Yeah, that one.
This one. Okay.
So given that the time is a factor here in terms of the ultrafine particle to the worker, would there have to be some kind of a period between cleaning and when the room is used by patients at the doctors, do you think, to be able to...
Sorry,
some period of time where the room should be left empty so that you don't get exposure.
You are considering the exposure of the patients.
Yes, after
For
disinfection.
The patient is there.
Okay.
We are considering here the exposure of the worker. That is different.
Yeah.
Because the worker, he goes inside, and then after the cleaning, after the disinfection, he goes out. So there is an exposure that depends on the time. For the patients, it's the same, because he stays there, and there is a generation, and it's much higher because, of course, this is limited to the time of the disinfection. For the patients, you have an exposure that is much higher, of course.
So is the assumption here that the disinfection is happening whilst the patient is in the room?
In some cases, yes.
Okay.
Disinfection, yes, of course. Consider an Ebola patient is there. The Ebola patient cannot be moved from the room, for example. In some cases, no.
Yeah.
In this case, Ebola patient or any other patient, so of course there is additional risk for that patient, but the patient at that moment has a bigger risk, and for the patient it's only the time when they are in the hospital, so it's not the worker who has exposure day by day, and so it's a difference. So I think for the patients this is kind of unavoidable risk, but relatively small risk because it's of a relatively short time. But in the questions of reoccupying, let's say that doctor's practice was cleaned after one patient, and then the question was when the doctor can come back with the next patient, because again, for the next patient, this won't be a big problem, but for the doctor who is coming back and back and back, they could be. So how soon the room could be reoccupied after the cleaning procedure? So this is potentially an issue.
I would like to know what is the ventilation status of this room.
This room, we had several rooms. This room means this one. Anyway, the ventilation was something like 0.5 air exchange rate per hour.
Okay, yeah, it's like...
the ventilation was very low.
Okay.
But the emission factor does not depend on the ventilation.
Yeah, but I think the ultrafine particle concentration will be changed with the ventilation status.
But we did this to estimate the emission factor. In the simulations, we varied the air exchange rates for the simulation. So when you know the emission factor, you can simulate in the same room as the ventilation varies.
Yeah, yeah, thank you.
Thank you. I was wondering, so if your emission factor depends strongly on VOCs, and if you reapply, so if your emission factor depends strongly on VOCs, and if you reapply the bleach, you don't really see much of the particle formatted, and your emission factor is per cubic meter, do you really think that you can just scale for the big rooms and small room by multiplying the square meters? Do you think the big room will be actually just multiplication of the emission factor by the square meters?
No, the emission factor, in my opinion, depends on the surface. The surface.
Yeah, but how much particles you will produce, it depends on the VOCs. And I'm not...
On the VOC, yes. Yes and no. Because there is the level of VOC is important in order to force the generation of particles. You can see here, for example, I will try to explain. This trend is practically the same if I vary the level of VOC. What is the difference? The difference is that in the chamber, this generation will, the time of the process will be very long if I have a very high concentration. If I vary, for example, the temperature, the generation is very high, so it's different. So the level of Vox force the rate of the generation of particles. Then if I have a different volume, I can have some differences, but I think there is not a variation of an order of magnitude, for example, of the emission factor. And anyway, the message for you, these are values that, in my opinion, are indications of the emission factor. Of course, there are a lot of parameters that can vary the value, but in principle, I don't expect a huge variation of the value.
Thank you for the presentation, really interesting. So in your model, you have different air exchange rate, and then you estimated the decrease for the ultrafine particle emission, right?
In the model,
you have the model.
In the model of Congruent, this one.
I can't remember, somewhere. So I think maybe you can think about there could be other loss mechanism for the particle. For example, the particle can be the chloride. I believe is volatile. The chloride species is volatile. When you have a high air exchange rate, you can have evaporation for the particle, not only just the mechanical ventilation.
I agree. This is a simplified. It's a simplified equation. We use this simplified equation also in other cases. So this is a simple evaluation. This is not.
So I believe the emission rate can be even lower, but we should also consider the counterpart in the gas phase, because after you evaporate, you have more gas phase.
You are right.
Yeah, thank you.
Just a quick comment. I think it's what Magdalena was aiming is your source of radicals, oxidants, is surface, but your source of particles is also in the volume or in the VOCs. So it's the surface to volume ratio of the room that would be that could be important, and that would not linearly scale.
This is a sophisticated.
I know. I'm just saying.
I understand. This is okay. Probably it's a second level of. Oh, wrong.
Thank you. That was a very interesting talk. I think there's a difference between emission factor and emission rate. And what you specified there is particles per minute, that's emission rate. So when you take the emission factor, when you compare the emission factors between spraying and wiping, do you take the same volume of disinfectant?
For sure, the same volume of water or solution was on the surface, the same. And we monitor it also because there is that this solution had to stay on the surface for 15 minutes. And we control this using a thermal camera in order to check if there is some points in the surface that was dry. Okay, so the same amount of liquid of a solution was on the surface, for sure.
That's good. Thank you.
Thank you for your presentation. I just want to ask, did you measure PM 2.5? Because when you talk about, for example, wiping and spraying, maybe we just consider about the ultrafine particle, but what is important is PM 2.5, and spraying maybe generate more PM 2.5 as a leading actually DALI and something like this, because the effect of health is more than others.
We measured the PM 2.5, but we have not found a generation, okay, of PM 2.5. But your question remind me why we started to characterize this kind of films, this one, because the company came to my group asking to check if these films were able to reduce the PM concentration in the air. So because so I said to them, okay, this is not possible. But this was a good opportunity for us to check if these films are able to produce ultrafine particles. That is the opposite. For them, it was not a good idea to come.
That's exactly one of the points I made. If you checked for PM 2.5 and ensured the producer report for the company that it doesn't produce PM 2.5, so the company would have then scientific evidence it's completely safe product. But the fact that it doesn't, but the company didn't ask a question about anything else.
But they wanted a reduction of PM 2.5.
That's right. Yeah.
That's
right. Any other questions? Or from the room or from the audience listening? No other questions? Well, I think we tired out Giorgio sufficiently asking all the questions.
Yeah.
So thank you very much again for your very, very important presentation and very interesting presentation. And we look forward to more work and joint work on this topic. Thank you very much.
Thank you to all of you.